Right.
She's going to be minus. I have to.
All right.
How do I just pass? How do I get out of doing pass? How do I do that?
All right, guys. Let me show you something on the calculator related to conversions. Oh, I always forget which one. Shit. Go away. All right. Let's say. So, are you looking at a specific problem in the homework?
The Babylonian conversion, number 18. Because I know on the review.
Oh, on the review.
Yeah. It was 1,943 to Babylonian, and I know you're supposed to divide that by 6.
All right.
Yeah.
I got you. All right. So let me show you. This is related to a mistake somebody made on the. I can't remember if it was the homework or what it was. So first off, remind me what's Babylonian. What's the baby? First couple of things here. Everybody starts with 1. And then Babylonian builds up by 60s. So one big mistake is to do this. That's a mistake. Because 60 times 60, there's 2 zeros. I like it. So for 1943, I don't need to go that far. Right? There's not 3,600 in 1943. They're just saying. So I can divide 1943 by 60, but let me show you, I don't know if this, let me just show you this, and you can tell me this is your question. If you do 1943 divided by, let me make this bigger. Large, all right. If you do 1943, shit. Sorry, I need to hire somebody. Divided by 60, you get something that it would be nice if it was useful. You get 32, that's the main piece, but then you get this other stuff. So watch this. That is the remainder in a way. That's not the remainder, but it's related to it. If I take 32 away, and then multiply that by 60, I'll get the remainder. Because that 0.3833 would be the remainder divided by 60. That would be how I would write the fractional remainder, right? It would be 32 and something 60ths. So how do I figure out what that something was? I multiply that piece by 60. So that's how you could use it. The more direct way to do this, of course, is to go, okay, 32 times 60 is 1920, and then I subtract that from the original to see how much I have left, and both of them agree with 23, right? Yeah. But what I just did, that's the way I do it.
Yeah.
Yeah. So I make use out of that decimal number there. If what I just did didn't make any sense and you're able to do these problems, don't do that. Don't worry about it. It's not necessary. Do it whatever way is working for you. Cool. I like it.
Can we go over number 10 or a problem of number 10? Up there.
Yeah. All right. Pretty much nobody liked the lottery problem on that test, but I don't know. Any problem I give you with several possible outcomes and probabilities that you can associate with them, if you can write it as a bunch of x's and a bunch of probabilities of those things, you just multiply and add. That's the idea. If I'm able to write it in that form, it's easy. So here I've got, where do you go? Earthquake Insurance Company. There's a 1% chance they'll have to pay $800,000. So this is the outcome. What's the probability of that?
1
Yeah, 0.01. 4% chance they'll have to pay, what was it, 50,000? And a 95% chance they won't pay anything. Thank God there's a decent chance that there will not be an earthquake. So the whole idea is you take the value times the probability plus the value times the probability. The book gives it more like a straight line kind of formula, and if you enjoy that, that's fine. There's something we do in statistics that's very much like this, so I just automatically think of it this way. So you just multiply these. 1, 2, 1, 2, so it's 8,000. 1, 2, 1, 2, so it's 500 times 4. 2,000, and then that's 0. Is that cool? So this is like the books, A times P of, or I think they do E times P of E1, E2 times P of E2, or whatever the hell they write it as, right? It's the value times the probability. And then you add them up. Say again?
Are there going to be like one problem probably of this on the test or exam?
Maybe 2 now.
Shut up.
I love that question. It makes me realize which ones I need to put multiple problems on. There's not going to be a lot of these, huh? There will now.
Yeah.
I'm joking. A little bit. All right, cool. Is that all right? I like it. So you can do the same exact thing with the lottery problem. You just got to realize some of you guys are buying 3 tickets on that lottery problem. Some of you guys are buying 4. So it's going to triple or quadruple the probability that it normally would be. If you buy 3 tickets, you should have 3 times the chance to win. Okay.
Excuse me. Sometimes when you use this solution for this kind of problem, you do negative.
Yeah, if so if you're playing a game where you got to pay to get a ticket, then you could have a negative outcome. Or there was a problem where you could lose money because your investment goes south. You could lose millions of dollars. Yeah. So if you're losing money, you got to put this as a negative. Yeah, so that it takes away from your expected value. Yeah. So this was all them paying to this customer. So this would be $10,000 going away from them. So how much should they charge if it was going to be a fair price? How much should they charge each customer to be a fair price? If they expect to pay $10,000 on average for every customer, for every client, to be a fair price, they should charge $10,000. Now, how much will they charge? Maybe $15,000. They're going to make a profit, right? Become too big to fail, and then wait for government bailouts. Oh, sorry. It's not politics. Cool. All right. It's good to see you guys.
Yeah.
Can you please do number 17?
Do you guys want the answer key for that final? Practice fine?
I'll take it.
The answer to the practice test.
I'm too nice. I was going to let you walk, but
Thanks. Appreciate it.
yeah, I thought you should put all the answers. Yeah.
Did you do number 15 for you? Because I think it's number 15.
On the practice fun? No, not yet. This is a good question because we didn't do a whole lot of this. Number 15 talks about dominance, which is the logic equivalent of order operations, right? Please excuse my dumbass son. Or Darren, Sally, whichever one you want. So it's got this here. This is where I was talking about something I call the super equals. Does that ring a bell?
Yeah.
Super equals?
Super equals.
So what's the most dominant, most powerful thing in there?
The by kind of.
Yes, the super equals, right? So that breaks it up. And the reason I call that super equals is this does the same thing, but this is more powerful. It breaks it up into 2 sides, just like an equal sign would. Right? Now, inside here, there's really nothing, no more parentheses to draw. It's R and not P. So that's straight up. I don't have to draw any parentheses. Here, though, inside here, of course, I just gave it away. What's the dominant thing inside here?
Condition.
Yeah, the equals, the normal equals. And then you're done. Bam.
So we start with the power, the most powerful.
Yeah, that's why it's called dominance. Whereas, well, I mean, order operations is the same way, but the order operations parentheses is a part of it. So this isn't exactly the same. This is, but this is how you do it.
Thank you.
Cool. Because this tells me the order that I'm going to evaluate these things if I had to make a truth table for this. Remember that phrase, truth table?
Yeah, we're
It's been a
really
while.
good at that. We're all super good at it.
Oh, okay, cool. I didn't know you had a spokesperson.
So it doesn't feel
He's right there.
No, now I feel good about putting a couple in there. I was like, oh shit, okay, they're good. Okay, good. Too bad, man. You can't win either way. Huh?
What's the truth then?
Table full of truth, man. You don't remember? Are you serious? Or I can't tell with you.
Honestly, don't know either. I'm 50-50 right now.
Number
Alright.
16, is that how we just...
Oh, true,
write
false,
it
false,
out?
yeah, I know that.
P is false and Q is true.
So now I know how to do 16. This is number 15. 16 says if P had the value of false, Q is true and R is true.
And we just plug them in.
And now you just plug them in. So it's just like algebra. But instead of algebra having an infinite number of possibilities for the variables, we only have 2. Yay. Yes, ma'am. Yep. So did you want to do a truth table example? Like number 17?
Yeah, might as well. Okay. All right.
So I think the thing you guys are going to definitely need to go back and remember is how to set up the inputs. And this is where I was kind of happy that quite a few of you guys came up with a better kind of way to do these. So I tried to do what I did by the book. I showed you a couple different shortcuts. But a part of math is to make it your own. So you say, okay, that's nice, but this works better for me. Beautiful, I love it. And sometimes I steal that from students. I'm like, it looks good. I'm going to teach it that way. Yay. Anyway, sorry. So I need to know what the inputs are. How many variables do I need?
3.
That's right, P, Q, and R. Always put them in alphabetical order so that everybody agrees. Who remembers how many? Oh, this is coming back? Yeah, P is the constant. He's like, true, false. Q's a little more hectic, right?
True,
True, false, false, true, false, false. And then R is just true, false, true. R is a little squirrel thing. All right. That's the way I remember it, anyway. And so now these act as your inputs, and there's a lot of different ways to do this. I'm going to just show you the book way. Some of you guys do this way that's called construction. I love it. Where you construct what you need for that, and if you do it that way, you kind of know what I mean. If you don't worry about it. So what's not P going to be? What's going to go here? Yeah, because it's true, false, so not P must be falses, and then trues. So I don't have to write R again because it's right there. So or is, oh shit, or is only...
It's only false when they're only false.
False when they're both false. Or is the dude that's very, he's like, you or you, I don't care. If neither one of you, then shit, I care. Right? But if at least one of you guys, I'm okay. So it's only going to be false when I see 2 falses. So that's false. That's false. Everything else is true.
Yay.
We stop there for a second. I don't need you anymore. Alright. And then if I figure out what this is as an answer, I can then do this between those. So I don't have to rewrite Q and P. What's and? And is only
True.
true when they're both true. It's the most restrictive one, right? It's like the evil bouncer. You got to be good looking and have a lot of money and have a nice car and be able to dance well and whatever. Know me personally. Right? It's like shit, and I got none of that. Okay. So Q and P. So it's true here and here. Let me see. Anywhere else they're both true? Aw. Poor little dude. This is where lined paper comes in very handy. And again, this shouldn't be a surprise. I knew when I drew in the parentheses for dominance, this was the most, well, I didn't have to draw this one, I'm thinking about the other one. But that's the one that's outside, that's the last thing I'm going to do. So it makes sense, I'm doing this last. Right? So just kind of make sure you're doing, it makes sense what you're doing last. So what's true about the if-then?
It's only true. It's only false if it's true and then false.
Exactly. It's only false if true implies false. You did what you said you had to do, what I said you had to do, and I didn't do what I said. You got an A and I didn't get your car. Ooh, liar. Right? So where's TF? TF. There's TF. TF. There's TF. There's TF. Oh shit, there's a bunch of TF. Oh shit. And then everything else is true. So then you circle that. That's your answer. Alright. Is that... Do you remember that?
Yeah.
Yes? Okay. Alright.
Recording this?
Yes. I record every lecture. Oh, I love that. The last day of classes. Do you record the lectures? Yes.
Can you do on the practice final number 4C, the sum of the terms and so on?
Where are we at? Sorry?
4C.
Where am I at? Oh, there it is. 4C. Find the sum of the first 7 terms.
Yeah.
So, what'd you get for the formula? Oh, well then we better start with 4B then.
Yeah.
4A even, yeah.
Well, yeah. I just don't know how to do this.
So let's see, find the sum of the first 7 terms. Well, actually, we could do part C directly. Because what kind of sequence is that?
Looks like times 4.
Good, all right, good. Because the main thing there is only going to be 2 options for this kind of problem. Either I keep adding something or I keep multiplying by something. And then you've got those formulas. By the way, if you want to, we can do like we can talk about formula sheet, but you can really just bring all your formula sheets with you as long as they are ones you didn't lose points on. And yes, people lost points on formula sheets, because if you put more than I said you can have, then guess what? You're going to lose points. There's a purpose for me saying you can't have certain things.
Are you going to give us the sheet you gave us 10
Oh, yeah. You mean the...
conversions?
Yeah, that sheet that had those beige boxes of numbers, conversions, and all. Yeah, that same sheet I'm going to give to you for the final. Yeah. I'm not suddenly going to say, you must memorize them. Okay. So we got 3, 12, 48, blah, blah, blah. So what's A1? What's your gut tell you A1 is? 3. Who to what? Oh God. Where do you go? Oh. So if it's a multiplication problem, what's the letter that I need to use here for the other variable? R, the ratio. There's a common ratio. 12 divided by 3 is the same as 48 divided by 12. So the common ratio is 4. And then, does anybody remember the formula? You start with A1 and you keep doing what to it? What do I keep doing to 3? Times 4, and then in 10 times by another 4. So times R. N minus 1. Remember that n minus 1 we talked about a little bit? If only they would have called the first thing A0, then that could have been an nth power. But the number of steps is always offset by 1. If I start at the first thing, how many steps does it take to do the second thing? 1. 1 step for the second thing. Oh shit, n minus 1, they're offset. If I would have called that A0, then it would have been beautiful. Too bad for us. So what's the formula in general? It's going to be 3 times, I just got to plug it in. Is that 12 to the n minus 1?
No.
PEMDAS will save your us. Right? You can't multiply before you exponents. How many 4s do I have here? N minus 1. How many 3s do I have? 1. So I can only make 1 12. And what good would that do me? None. I can't make n minus 1 12s because I don't have n minus 1 3s to go with my n minus 1 4s. Does that other way of looking at it make sense? Just one of them makes sense. Order operations. You can't do that. You can't combine these. So that's part A. Part B says, what's the 7th term, right? Yeah. So all I got to do for part B is let n be 7. It's crazy. I want the 7th term. 3 times 4 to the 6. It's amazing. And then you can throw that in the calculator. I'm going to multiply 3 by 4 6 times so I can get to the 7th term. And then whatever the hell that is. And the sum formula is this weird thing. Only weirdos like me would remember it. And again, it's really just plug and chug. Are you able to put the numbers in the right place? And then secondly, are you able to put all that into the calculator correctly? So it's funny how students always want to use their calculator and then they don't use it right. I'm like, well, I didn't do any good. So this will be 3 times 1 minus 4 to the 7th, because I want the sum of the first 7. 7 sum of the 7th sum. 1 minus 4 again, right? It's kind of repetitive. And then just throw that. What's 3 divided by 1 minus 4? What's 1 minus 4? Negative 3. 3 divided by negative 3 is... Some of this you should be able to do without a calculator. And that's beautiful because then you take away this division thing that always screws people up. So that's negative 1 times whatever the hell that is. So do 1 minus 4 to the 7th and then change the sign. That's all you got to do. This is why we want you to be able to do stuff without a calculator, because it makes it easier to use a calculator. I do not know what 4 to the 7th power is. And I'm okay with that. So I don't know what you get, whatever you get. Oh. I'm going to give you guys the answer key. I have some that are stapled and some that are not. All right, so. There's one for him, there's 3 for them. This is page 1. Did you get one? There's one in there for you too. Wow. There's page 2. I think, right? Please tell me I give you the right one, yeah. Sure, okay. Can we handle this? There's 2 pages. Just because my printer does not have stapling options.
Missed that. 4 will always be for that one. No, it was over here. No, I was like,
Yes.
Beginning is better, but some of the numbers are good. We still have it missing.
Let's see.
like 5, 8 to 8, 4, I wrote like 7 or
Oh, okay. I don't know why I did that. I wonder if I might not have updated your, let me make a note.
I did all my homeworks on that.
I might have just wrote the wrong thing in the wrong.
I don't have that
column.
with me, but I know I did that one too.
Oh, here, keep this. Let me put a note here. So this is 401 through.
8, 4. And then that was 12.7. That's the last one.
So, and then should. Oh, so it might just be me putting the wrong thing in that spot. So
If I don't submit the homework, then on the final I have to get this.
yep.
And then if I do
I'm
all
so
of
done.
them, then I'm gonna get this.
What?
So I have to get this.
Yes.
To pass with this.
Yeah. Well, and now of course a lot of it would be late, so it'll be somewhere in between those two grades. Yep.
It says I'm missing these two, the last two homeworks, but I have them right here, and they were in the packet.
Okay.
Way too big packet that I give you.
Okay.
Thank you.
One more question. Most of this I know I didn't do, but
One of them I said you could redo.
do I do it?
Yes, and on the quiz itself it says redo for up to whatever. Yeah. So guys, keep me honest now. Don't take it personal if I say I'm missing something that I shouldn't be. So just double check the missing homework. Make sure that it's correct. Let me know if it's not. On the day of the final, I'll have the spreadsheet up here so I can make changes right in it so you can see them happen. Okay.
Wait, so can we do any formula sheet?
Oh, yeah, okay. All right, so let's just march right through. Help me with that. Keep. By the way, here's the videos of all the lectures from this semester. So you can search by 120. And if you watch them and you turn on the closed captioning, it's especially hilarious.
Oh, I always use closed caption.
It's funny what it thinks I'm saying. All right. Let me see if I can strike a balance here. So chapter 1, there really was no formulas. I don't know if you remember chapter 1, we talked about inductive versus deductive reasoning. It's our first little foray into sequences, not all the way, just it could have been any kind of sequence. Estimation was in there. Word problems in section 1.3, sort of, not really. Just use the numbers in the right way. So that was chapter 1. It was about critical thinking, deductive reasoning, those things. And then chapter 3, logic. Let me think. No real formulas there. No. So we had, truth tables. We had if, then, all that kind of stuff. We had Euler diagrams. That was where 3.7 was extra credit, I think, this semester. Yeah. 3.6 was the Euler diagrams. All men are mortal. Socrates is a man. You can prove he's mortal. He's not still walking around somewhere as far as we know. All right, so no real formulas from chapter 3. Say again?
Democon said no P and Q equal with no P or no Q. Am I right?
Oh, De Morgan's.
Yes, De Morgan.
I don't think I let you write that down on a formula sheet, though. I'm pretty sure I made you know those.
You made us memorize.
Yes, oh shit. So that still holds. So remember, De Morgan's was, and it should be relatively easy to remember,
Yeah, it's easy to remember.
because it seems like distribution, but it changes everything. So this will be not P or
Not
not Q. I like it. So it just changes everything. Okay, cool. I think our first, and then chapter 4 was number systems. Let me think. I gave you that sheet that had everything on it. I don't think there was anything in addition to that I had you write down. I had the Mayan base on there even. I just made you remember the pancakes and blueberries. Remember pancakes and blueberries? Mayans are famous for their pancakes and blueberries.
I totally failed that history class.
What's that?
I totally failed my history class. That is not what I put.
Oh, that's bad. That's bad. You have to take this one first. And then, of course, then there was the changes of the different base numbers in 4.3, 4.1, 4.2 Romans and Babylonians. So you have to know what you had to know then, and I'm going to give you what same thing I gave you then. Okay. The first real formulas we hit were the ones we just were doing, the one for arithmetic sequence. And the sum of that, we talked about this little urban legend here. There was an urban legend that went behind this.
Bloody Mary.
Not one that you would make a movie out of. Yes?
So these are for like for the sequence 3, 12, 48, 1, 2, that's the
Yeah, it's coming up.
yeah.
Not yet. So this is for one based on addition. And then the one that's based on multiplication is the one we just did an example of. Cool.
We got these two all.